Welcome to AulaUE. My name is Maria, and today we are going to talk about confidence intervals. In the following table, we have summarized the most important cases for confidence intervals. For the normal distribution, we have the first case, mu when sigma is none, and the formula to compute the confidence interval is just the following one. You have seen the explanation in class, so I'm not going to explain it once again. Here, let me just remark that you need to compute in the normal distribution table the value of set alpha halves because we leave alpha halves probability in both parts, right and left. Okay, let me just remark that for this first case, we need to find out the value in a normal distribution table because we are in the case when we want to compute the confidence interval for mu when sigma is none. In the second case, the confidence interval for mu when sigma is a none, the formula is just the following one. In this case, instead of using the normal distribution table, we employ the T distribution table, the T student distribution table. And let me just notice that we use T of alpha halves with n-1 degrees of freedom. So in both cases, we need also to include this T alpha halves n-1. Okay. In this case, let me just remark that these are the values that we need to look for in the t-distribution table, and hence that's the distribution that we have to employ in order to calculate the confidence interval. One important fact that distinguishes this interval from the previous one is that since sigma is a none, we cannot employ it in the formula, and instead we use just the standard deviation from the sample S. So when we do the calculation, we have S over square root of n. Okay, in the third case, when we want to calculate the confidence interval for sigma, we have to employ always the t-square distribution table, and we have to find out two different values. T-square of 1 minus alpha halves n-1 is just the first value here in the table, in the picture, and the other value is the t-square distribution table for alpha halves n-1 that corresponds to the second one. So pay attention, biggest value will be in the first position and the smallest value in the second one, in both cases from the t-square distribution table. Okay, the last case is for the binomial distribution. In this particular case, we want to estimate p the proportion. So let me just remark that in all the cases we are using p hat, the value from the sample, and of course q hat is just 1 minus p hat, in this case the complementary of p, so you can easily compute it also from the sample. So in this particular case, once again we use the normal distribution table, and we just need to compute set of alpha halves, because in order to define this confidence interval, as we have seen in class, what we have to do is just using the central limit theorem to find out the formula by doing the approximation of the binomial using the normal distribution. And that's all. I hope you enjoyed this video.